So the next thing that we can actually do with complex numbers is we can multiply them. So when I say multiply, I basically mean just multiplying it like the factors of a quadratic equation. So remember, we used to multiply such factors, and when you multiply them, you have to do step-by-step multiplication. First, this multiplied by this, and then this multiplied by this, etc. In the same way, we do it with the complex numbers, but there is one interesting fact that I have to tell you about. So let's try to multiply two complex numbers. So let's say 2 plus 2i multiplied by 3 minus I. Okay, so these are two complex numbers that we are going to multiply with each other now. So here, 2 times 2 gives me 6. 2 times negative I will give me negative 2i. Then 2i times 3 will give me 6i, positive 6i. And then 2i times negative I will give me negative 2i squared. And next, we need to simplify all of that, because on the SAT, you will always have to provide the simplest possible answer, or the most simplified form of an equation or expression. So let's take a look here. We have 6 minus 2i plus 6i. Well, these are like terms, and we can actually simplify them. This gives us 6 plus 4i, then minus 2i squared. What is that? So minus 2i squared can actually be simplified to minus 2 multiplied by negative 1, because do you remember I squared is negative 1? So I squared in such cases must always be simplified to negative 1, because as I said, we will simplify it to the most basic form, and for that we need to eliminate everything that we know. In such case, 6 minus 2 times minus 1 will give me 6 plus 2, and that will give me 8. So all of that is equal to 8 plus 4i. So as you can see, when we multiply complex numbers together, we actually get a different complex number. This is an operation that you should be able to do on the SAT. So let's try to maybe simplify another multiplication of complex numbers. I will write it here on the board, and I'll ask you to do it by yourself. And of course, then we will do it together. So simplify 3 minus 2i multiplied by 3 plus 5i. So I hope you paused the video and tried to do this by yourself. So let's take a look here. 3 times 3 gives me 9. 3 times 5i gives me 15i. And then negative 2i times 3 gives me negative 6i. And this multiplied by this gives me negative 10i squared. Immediately, we can simplify some terms. So 9, and then here I'm going to have negative 10 times negative 1, which just gives me positive 10 plus 10, and then plus 15i minus 6i just gives me 9i, or positive 9i. That gives me 19 plus 9i. So I hope you were able to simplify that. Now let's take a look at if we did everything correctly. I'm going to now verify. Indeed, 3 times 3 is 9. 3 times 5i is 15i. Negative 2i times 3 is negative 6i. So indeed, everything so far is correct. Negative 2i times 5i gives me negative 10i squared. And then I simplified everything. 15i minus 6i gives me indeed 9i. And then this is going to be negative 10 times negative 1, which just gives me 10. So I write it here as an addition. Perfect. So please always remember to verify your answer. As long as you verify your answer, as long as you can prove that you did everything correctly, then we have no problems. So far we talked about two things that you can do with complex numbers. You can add them and you can also multiply them. Here we are also going to now talk about another definition, another very important term, which is called complex conjugates. So complex conjugates. What is a complex conjugate? How do you find a complex conjugate? All right. So if you have a complex number, the complex conjugate of this complex number is going to be equal to the same real part plus the opposite of what you had in the imaginary part. So for example, you have plus 3 here, plus 3i, The opposite of that would be minus 3i. So the complex conjugate of 2 plus 3i is 2 minus 3i. So why is that important? Well, I will come to that fact a little bit later. It's important for a certain operation. But now let's take a look at another example. What is the complex conjugate of negative 2 minus 3i? The complex conjugate of that would be negative 2 plus 3i. As you can see, I do not change the sign of my real part. I only change the sign of my imaginary part. You can write complex numbers in a different way. You can write them like this, 5i minus 3. In such a case, the complex conjugate of that would be negative 5i minus 3. So I again change the sign of the complex, the imaginary part, and the real part stays the same. So find the complex conjugates of the following complex numbers, please. So I hope you were able to do that by pausing the video. Now this is 21 plus 7i. Very simple. The next one is pi minus 2i, because pi is a real number, we don't change its sign. And last but not least, you have 8. So this is plus 3i, right? We can rewrite this 8 plus 3i, and that's going to be in the complex conjugate form 8 minus 3i. I hope that's understandable. So why am I explaining you about the complex conjugates? Well, because complex conjugates can be multiplied to give a real number. And I'm going to demonstrate it to you right now. Let's say we have two complex conjugates multiplied by each other. So these two complex numbers are the complex conjugates of each other because their imaginary parts are different, the opposites basically. So if I'm going to multiply these, what I'm going to get is 2 times 2, which is 4, 2 times negative 3i, which is negative 6i, 3i times 2, which is positive 6i, and then 3i times negative 3i just gives me negative 9i squared. What I can do here is I can cancel this, because this and this, they cancel out, they give us 0. So all of that is equal to 4 minus 9 times negative 1, because I squared is negative 1. And that overall gives me 4 plus 9, right? So that gives me 13. So as you can see here, if I multiply two complex conjugates together, I'm going to get a real number. That is a very important fact and something that you should definitely be able to know and be able to do. So, sorry, be able to know is not the right expression, but being able to know something comes from having seen it at least once in life. So I hope you have memorized or at least understood this, so that in the next time when you have to multiply complex conjugates together, you know that you will have to get the real number at the end. Now let's try to do that. Let's try to practice. So let me give you a complex number here and a complex conjugate of that complex number right here. So try to simplify this as much as you can, please. So negative 1 times negative 1 gives me 1. Negative 1 times 2i gives me negative 2i. Negative 2i times negative 1 gives me positive 2i. And then this multiplied by this gives me negative 4i squared. So 1 is rewritten. This goes away because these two cancel each other. It's just equal to 0. And then you have negative 4i squared, which is negative 4 times negative 1. And in total, that gives me 5. So this entire thing is equal to 5. This is a very possible SAT example. You may come across this on the exam. In such cases, you should just be careful while multiplying.